Hey everybody, this is Amy Astro and welcome back to my channel. It's been a long time since we have processed an image, so since I have this fresh data here, I thought maybe we should process it together. So in this video, we are going to process a one-shot color camera image in PixInsight. Hang on! So guys, this is M33, the Triangulum Galaxy, and I took it with the ZWO ASI 183 color cool camera, along with a 0.8x reducer. Telescope was an Explorer Scientific ED102 with the FCD 100 glass on my Skywatcher EQ6R mount. All right, and I took this here in my yard. Now what's interesting about this image is it's one of the very few that I was able to accomplish taking 10-minute long subs. Now of course it crashed after the meridian flip on me that night, but I did successfully get 2 hours worth of images. So this image was comprised of 12 10-minute images with a gain of 139. All right, so let's hop over to PixInsight and let's get this ball rolling. Okay, so I am here in PixInsight and I have loaded my template project. You'll see one of my early on videos that does show you how to create this template project, and I'm going to show you the files that I have here. I have my main directory for M33, and I generally create directories for print, my edits, and then I've got my darks, flats, flat darks, and lights. And I have already set up my directory structure. And this tells me how I'm going to walk through the project so I don't skip a step. All right, but here you can see my 12 images taken at 10 minutes each. All right, so let's get started with our calibration frames and getting our master files together. Let's start with our darks, and we're going to use image integration. I'm going to add files. I'm going to go to where my files are here, M33 dark. 600 seconds. I'm going to grab all 25 images and say open. Okay, I'm going to do combination average, additive scaling. Noises, I don't care. I'm going to make them all equal to 1. I'm going to generate an integrated image. I don't need to evaluate noise, so I will uncheck that. Let's minimize. Let's go to pixel rejection. Let's see, we have 12 images, so that means Windsorized Sigma clipping. And normalization, we are going to leave it at scale plus 0 offset. Okay, I don't want to see any of the rejection maps, and I'm just going to do the low and high pixels. And let's go ahead and apply global. All right, so our master dark has just been created. Let's give it a stretch and see what it looks like. All right, so you see all of this. This is called our amp glow, and this is rather terrifying to see on an image, but just know through this calibration process, we will eliminate every bit of this, which is also in our images. Okay, so do not panic. I'm going to come over here to where it says integration and right mouse click and identifier, and let's change this name. I'm going to call this master dark and say okay. And let's do a file save as, and I want my file type to be the standard file type for PixInsight, which is XISF. Let's go back to my directory structure, and I'm going to just drop it right here. We'll say save. All right, now I can close that. We have our master dark. Well, let's go ahead and do the same thing for our master dark flat image or flat dark, however you call it. Let's go to image integration. I'm going to clear these images, add files. We will go to our flat darks, which are 0.65 seconds, the same exposure that I took my flats at. I will say open. And let's see, I have 25 images, so let's change this to linear fit clipping and apply global. All right, so now we have our flat dark image here. I'm gonna minimize this. I'm gonna change the identifier to master flat dark. Okay, and let's do a file, save as, and it is called master flat dark in the XISF format, and let's go ahead and save it and say okay. All right, let's give it a stretch, just see what it looks like. You see, it doesn't have all that glow that the previous 10-minute image did, and that's because the longer the exposure, the more of that glow that's going to show up. And this one was only at 0.65 seconds. Now that I saved it, I'm going to go ahead and close it, and let's move on to the next step. The next step is we need to calibrate our flat frames. Let's go to image calibration, and let's go ahead and add our flat frames. Here they are. And I'm going to grab all of those and say open. Now output directory, since we are calibrating these, let's get to the right spot here, will be flat cal for our calibrated folder. Okay, and this will stay the same. I will not use any bias frames, it's not necessary. My master dark. This is going to be my master flat dark because it's taken at the same exposure as the flat files. So use the master flat dark and say open. And I'm going to close out the master flats because we are making the master flat. Let's see, I don't need to optimize, but I am going to calibrate. And the reason I don't need to optimize is because my dark is taken at the same exposure as my flat frames. If I was doing this the old way and I would have used my 600 second flat 600 second darks, then I would have to optimize this. And this image is going to turn out much better by using a dark that's taken at the same exposure as the flats. So let's go ahead and apply global. All right, I'm going to clear these out and minimize this. So now that I have calibrated all of my flats, I'm going to have to integrate it into a single image. So let's do clear. I'm going to add my flat files, the calibrated versions. Okay, so combination will be, let's see, average, additive with scaling. Nope, I want to do multiplicative. And I still don't really care anything about my noise as far as weights go. I'm going to make a single image, leave the automatic buffer size checked. Okay, I have how many images? I have 26 images, so I'll use linear fit clipping. And normalization, I'm going to go with equalize fluxes. And I'm just going to clip the low and the high pixels. And I don't believe I change anything else with this. So let's just apply global. All right, we've got our image here, but it doesn't look all that impressive. And let's just make sure that, I know I have dust bunnies on my lens, but if you ever get this type of image and you are unsure of whether or not it contains the dust bunnies, I do see one up here, but I'm going to use the histogram transformation just so I could prove to myself that this is correct. I did a live view here, and I'm going to play with the darks of it and the lights of it and just see what comes out. And if you can see down towards the bottom of that image, there's some more circles here, which are the dust bunnies that I kind of knew I already had. All right, so this flat is good. I'm gonna close this out without making any changes. And let's change our integration right here on our identifier to master flat. And I will say okay. We're gonna do a file, save as, and put it in the directory with all of our other masters. And I will hit save. All right, so now we have all of our calibration masters, and we can actually start working on our light files. Now to begin with, we're going to want to calibrate our light files. Let's go to Image Calibration, and let's go ahead and add our 10-minute images. All right, here's my master images that I started with. Let's open them. Let's give the output directory. It's in a light folder. It's called Light Calibrated. I don't have a master bias, but I do have a master dark, and that's that 600-second one that we created. And let's go master dark right there. I do not need to optimize it because it is the same exposure as my images. I'll go ahead and calibrate it. Master flat. And that one's going to be this one we just created, master flat, and say open. And I'm going to leave it just like this, and let's run it. All right, I'm going to close this out. So now that we have our calibrated image, we want to go back and do the next step. So what's the next step after calibration? It is Cosmetic Correction. So let's go to Cosmetic Correction. We are going to add files, and those files are the ones that we just now calibrated. Grabbing them. My output directory will be the Cosmetic Correction directory. I'm going to use a master dark, and that is going to be my 600-second dark. So let's go back in here, master dark. Now I'm going to double click on one of these just to open it. Let's give it a good stretch. And I am going to zoom in on an area that is solely background, not stars. And I am just zooming in with my mouse wheel. And let's make a new preview right up here, new preview mode. And I'm gonna click, drag, and make myself a window of just the background. Let's open up the preview here and let's zoom, zoom, zoom. All right. Now we are going to see what happens to this as we change our hot pixel threshold. Let's do a live preview, nice and large here for us. And I'm going to enable the hot pixel threshold. And the Sigma section here is currently at 50. And I am going to drag it down and watch over here for what could be my hot pixels disappear. This image doesn't have any that are really obvious, which is great, but also down here, the real quantity. Watch that number, because if I bring this all the way down, you see I got a lot of pixels disappearing, but they don't really make a whole lot of sense. And it has me removing 86,005 pixels. That's way, way too much. Okay, so it's probably getting rid of good stuff pixels. So I'm gonna bring this back, and I'm gonna, let's see. I see as I move this back and forth, oops, I am watching the pixels change for me. And when they stop making sense, see this pixel right here, it doesn't make sense to me. But I'm at 2,465 pixels. That's probably just fine. There we go. That's where I'm going to sit at. My sigma of 14. Most of the time my sigma is about 3. Okay, so this is one of the few images that I'm actually leaving it higher than I typically would. And all I have to do now is apply it globally, and it's applying this correction to every image in that directory. All right, it says 12 have succeeded, which is terrific. I'm going to close this, clear, and this preview here, I no longer need it. So I'm going to go up under here, preview, and say delete all. And that just leaves me with the image that I opened, and I'm going to go ahead and close it. So we've calibrated, we've cosmetic corrected, and now we need to add the color back to our image. Let's go to Debayer. This particular camera has a bare mosaic of RGB, which is pretty typical amongst the ZWO cameras. If you are ever in question, go to the manufacturer itself and they will tell you in their specifications what their mosaic pattern is. Okay, so I'm going to combine into a single RGB image. Well, each image is going to be an RGB image, and I'm going to add the files that we just ran through the Cosmetic Correction, and we will say open, and I will output them to the directory that says Debayer on it. And now we just apply. All right, that is now complete. I'm going to reset this, close it out, and the next step is we are going to use that subframe. What is it called? It's image inspection here. SubFrame Selector. All right, this is that joyful one that they've decided to turn it into 3 separate windows. Okay, we're going to measure our subframes. So let's go ahead and add all those that we just now debayered. And we'll say open. Okay, this right here is the scale of your camera telescope combo. Now earlier I said that it was my Explore Scientific. I stand corrected. It was actually my Altair Astro 80mm telescope that I used. So I'm going to come over here to my ever-loving OneNotes, and I did a cut and paste from the astronomytools.net website, where I put in my Altair telescope, I put in my ZWO camera, I put in my reducer. It came back here and it said my resolution is 1.29. Now that 1.29 goes right here, 1.29. And camera gain, I'll leave that at 1, it's not going to matter. Camera resolution, 8-bit, I'm just going to leave it there. And let's see, I am not going to change anything else in these pull downs except for my output directory, which will now be the one that has calibrated, cosmetic correction, debayered, and now approved images. Select that folder. Keyword's going to be SS weight. Now over here, I need to come up with an approval formula that I'm going to use. Now I do not have to do this. I can look at the graphs when it's all said and done and pick and choose what I want, but I'm going to make my life easier, and I'm going to type in FWHM is less than 6. Now this is telling me that my largest star isn't going to be greater than 6. Now, if you have Alnitak in your image, you may want to make that a bit larger, but typically this is pretty good. And I'm going to do and my eccentricity is less than or equal to 0.6. Now, 0.4 or less is the perfect round star. Once you get past 0.7, you start seeing some dragging in your stars. So kind of the goal is not to have that dragging. And our weighting is going to be SNR weight. I have found that PixInsight is rather case sensitive, which will drive you absolutely bonkers. So now to apply this, I'm going to double click the execute and double click the execute, measure, and let's apply it. Now this is just measuring it. It is not outputting anything right now. So we still have final say of what we want to keep or get rid of for this image. All right, you can see my graph is kind of all over the place here. I'm under 6, I've got a couple that are smaller. That's okay, but this is rather tight when you think about it. 5.3 to about 5.95. That's a pretty good range. Let's look at our eccentricity. And everything is definitely underneath the 0.7, which is my scary zone. And it is also a little bit all over the place, but overall, these numbers are just fine. So I want to go ahead and use these. Now, if I did not want to use these, I would take this check mark and I will double click on it and say I'm rejecting that image. Or I can double click on it back and accept this image. See, if they automatically reject some images, but you feel like it's good enough, go ahead and accept it. It's not a big deal. The more images you get, the more picky you can be. I've only got 12 images, so I'm not going to be overly stressed, but even still, these are really good numbers. So come up here and where we measured before, now we want to output them, and let's run them. So now it's going to fill my directory with all of these images that I just approved, and I added a keyword to them, which is ssweight, and we will use that during the integration process. All done, let's close out of there. So now let's come back. We have gone through our approval. The next step is we need to do some registration, and that is our star alignment feature. Now I'm going to grab a file. I can choose any file I want. Typically I grab the first one. They say that you need to use the best one, but a lot of times I forget which one in all of this is, and I need to use the same one in the next step. So it's easier for me to grab the first one. And I will say, okay, I want to generate my Drizzle data, and I'm going to add those approved subframes that we just found or just created. I'm going to grab all of those, say open. I'm going to output them to this last directory. All right, now star detection. This is a galaxy image, and since it's a galaxy image, there was not a lot of stars really in this background for it to line up on. So what I need to do is bump things in my favor, and that's underneath star detection. If I was a nebula, this would be no issue, but default, I believe this is a different number. Bring your log sensitivity down to -1. It will help you greatly. And do your ransack tolerance, let's bump it up. This allows for misshapen stars, just to a higher number. Okay, so now that I've done those two steps, I'm going to say apply global. And with luck, over here in our process thing, it will tell us that we have all 12 images are star aligned. Now, if you have images that you think should have aligned with everything else, play with that ransack number and play with that log sensitivity number until you can get them to register together. Galaxies are about the hardest for me to get registered, particularly the whirlpool. That is like my nemesis target. Getting it to line up is tricky, so be patient. If you believe it should line up because it looks like a great image, play with those numbers until you make it happen. And here we go. Star alignment, 12 successful, 0 failed, and none were skipped. Perfect, exactly what I wanted to see. Now that all 12 images are aligned to each other, I'm going to go through local normalization. I'm going to open this up, again, file, and I'm going to grab that first image again, but it's going to be grabbed from this last directory. The first image. Now, I do not change any of these. I generate normalized data. And let's go ahead and add all those images from that last directory. And output directory will also be that last directory. We're going to be overwriting these images a few times in this one particular directory. And let's apply global. Local normalization has just completed. 12 are successful. So I'm going to hit reset and minimize this folder here. Now the next thing we need to do is we're going to integrate these images. It's time to combine them into one. I'm going to give this a reset from the last time. Let's add our files, and they're all the files from this directory. I'm going to add all my normal files, which are also in that directory. Let me show you though. Look, they stop with a different suffix. on here, file extension. Let's open and let's add our Drizzle files, which should also be in that directory. Notice it knew what it was looking for, and that's these Drizz ones. And we will say open. Oops, I guess it helps if I select them. Open. Now, image integration. We're going to use a combination of average. I'm going to use the normalization as local normalization because I did use normalization here. The weights here for noise, we're going to use the fits keyword, and that keyword is our SS WEIGHT. That's what we had applied in that SubFrame Selector. Generate an integrated image, generate the Drizzle data, evaluate noise. Let's close that, see what the next one is. Rejection, 12 images, so that's Windsorized Sigma clipping. Normalization will be local normalization. I don't care to see any rejection maps. I'm going to leave clip low, clip high, and clip low range selected. And all these others I will leave as default. And let's do global apply. So with luck, all of these are going to come together as a single image. And don't be surprised when you see the single image if it has a solid color over it. That is just light pollution or atmosphere. It's no big deal. We are going to get rid of that. All right, here is our image. Let's look at our process console. Take note, it took 49.653 seconds to do this, and that's because I am on a rather beefy computer. This could take 5 to 10 minutes. It just really depends on the processor speed you are using with your computer. All right, so here is my image. Let's give it a stretch, and it has this beautiful blue on it. And I'm pretty sure we don't want to keep this blue, but it is quite pretty. All right, let's clear this, minimize it. The last step we do is we're going to come over here and we're going to use Drizzle integration. And this is where it's going to pull out some extra bits and pieces out of this image that are not desirable. So I'm going to add all of these files in, back again. I'm going to say open. I'm going to leave these as default. I don't really care to see the rejected pixels. It just takes up more space. I'm going to enable image weighting, enable surface splines, enable local distortion, and let's see. Oh, I could do enable local normalization. Let's go ahead and add those normalization files here. Open, and you see they've all got ends by them because I now have a file that matches up with it. And let's just go apply global. Now when both images come up on the screen, you can take on your own and zoom into both of them, and you can determine if it looks better or not better. Typically I just run with it and just trust in the system. It works. All right, our image is complete through the drizzle phase. Let's see what the process time took. It took 1 minute and 59 seconds. Really not bad at all. I'm real pleased with that. Let's give it a stretch. And you will see here, it looks just like the other image. But there will be subtle changes here. I'm going to zoom in and just see if we see any of them. Sometimes we do, sometimes we don't. I'll take a wing at saying the drizzled image looks a little bit smoother, but it's too early to tell. Not going to stress out over it. I'm going to close the actual integrated image because I don't need it anymore. What I'm going to keep is our new Drizzle integration version. So let's change the identifier. I'm just going to call this M33. And now all of our 12 images have been merged down into one. So folks, we're going to end this video right here because we're already at the 30-minute mark and I'm sure everybody is ready for a break. So this video, to paraphrase, we covered everything from your raw images through calibration until you had a single image. In the next video, we'll pick up right here and we will finish the image all the way through, and I might even throw in a couple Lightroom tricks for you. So stay tuned. Thanks for hanging with me, and I will see you all in the next video. Goodbye, y'all.